The recording is started. You can proceed. Thank you.
Thank you. Good morning. I'm Santa Timinia, Acting Director of the National Eye Institute, and I'd like to call the 156th meeting of the National Advisory Eye Council to order. I'd like to welcome the National Advisory Eye Council members, NEI and NIH staff, and members of the vision advocacy and stakeholder communities to today's council meeting. As I turn the meeting over to our new Executive Secretariat, I'd like you to join me in welcoming Dr. Kathleen Anderson, the new Director of the Division of Extramural Activities. Dr. Anderson joined the NEI about a month ago and comes to us from the National Institute of Nursing Research, where she has been Acting Director for their Division of Extramural Science programs for the last year. At NINR, Dr. Anderson provided scientific, administrative, and policy leadership for all NINR extramural scientific review, grants management, and advisory council functions. Prior to that position, Dr. Anderson served the National Institute of Mental Health for 18 years, beginning as a program officer for their Neural Basis of Cognition program, moving to Deputy Director of the Division of Developmental Translational Research, and finally to Deputy Director for the Division of Translational Research. During her time at the NIH, Dr. Anderson has worked on such topics as cognition, brain development, and health disparities. She earned a bachelor's degree in biophysiology from Vassar College and a PhD in neuroscience from Rutgers University. She completed a postdoctoral fellowship in the neurophysiology of attention and memory at MIT. So please join me today in welcoming Dr. Anderson. Kathy?
Thank you. Thank you, Dr. Timinia, and good morning, everyone. It is a real pleasure to be here. I am really excited to join NEI. I want to first express my sincerest thanks to Annie Schaffner for her service as Acting Division Director and Executive Secretary for Council over these past 2 years, and for planning this meeting, managing the logistics, and most importantly, for her expert guidance since I've joined NEI. I have a small virtual token of appreciation for her, if I can get this to work, if you will bear with me for just 1 second. Does that work? Can you see my screen? Yeah, thank you, Annie.
Thank you. Thank you so much.
Yeah, you've just been terrific, so thanks so much. Let me go back, okay. So I also want to thank NEI staff, all of whom have extended me a very warm welcome. I want to echo Dr. Timinia's welcome to the National Advisory Eye Council members for joining us today. We very much appreciate the expert advice that you provide to NEI, and also echo her welcome for the NEI research and advocacy community, NEI and NIH staff, including staff from the Center for Scientific Review, as well as members of the public. I look forward to working with all of you. Just a couple of housekeeping issues. To state the obvious, we are continuing with virtual meetings this round, and we are pleased that you could join us remotely while we try to stay safe and healthy. We are all getting really good at Zoom etiquette, but just a few reminders. Please mute your lines when you are not speaking to eliminate background noise. Please turn off your videos. If you are presenting, please turn on your video as I'm introducing you so we know who is presenting, but then turn that off so we can ensure that the sign language interpreters remain front and center on the video cast. If you want to ask questions after each presentation, please use the raise hand function and we will call on you. Be sure to unmute yourself and be sure to state your name before you ask the question. Following the question, you can remute yourself. You can also ask a question using the Q&A function in Zoom, which we will be monitoring. The open session is being broadcast live and will be archived on the NIH webcast website, videocast website. A separate Zoom invitation for the closed session of council was sent out to council members and applicable staff with login instructions. Please email Annie Schaffner if you have any trouble logging into the closed session. I need to remind council members that as special government employees, you may not engage in any lobbying activities while you are receiving pay from the federal government. That is today. I will be giving more specific instructions about conflict of interest and confidentiality rules at the beginning of the beginning of the closed session later this afternoon. If you haven't already, council members, please sign the pre-meeting conflict of interest forms and return them to Latifah Hell. I'd now like to go to the consideration of the meetings, the minutes from the June meeting. Minutes from the June council meeting were made available to you in the electronic council book prior to this meeting. Would anyone like to discuss the June council meeting minutes? Okay. If not, then I need a motion to approve those minutes. Can I get a motion?
So moved.
Thank you. Can I have a second?
Second.
Thank you. All in favor of approving the June minutes, please raise your hand. Actually, I'll do it a different way. Is there anyone who is not in favor? I'll take that as a no. The motion to approve passes. Thank you. Dates for future council meetings are listed on the open session agenda in the electronic council book and on the NEI website. Please let me know if you have any known conflicts with those dates. Our next meeting is scheduled for February 12th in 2021 and will be held virtually again. I'll now turn the meeting back to Dr. Timinia for her director's report, and I will turn off my camera.
Thank you, Kathy. I know we're all looking forward to face-to-face meetings again, but we're certainly glad that we have the capability to conduct our work with you and to conduct our council business virtually. We don't have any new council members this round, and we don't have any members rotating off. So now is usually the time where I share staff announcements, and this morning's first announcement is very exciting for the NEI and for the larger vision community. As most of you know, on July 24th, Dr. Francis Collins, NIH Director, announced the selection of Dr. Michael Chang as the new NEI Director. Dr. Chang is currently the Knowles Professor of Ophthalmology and Medical Informatics and Clinical Epidemiology at Oregon Health and Science University. Dr. Chang earned a bachelor's degree in electrical engineering and biology from Stanford University, and a master's degree in biomedical informatics from Columbia University College of Physicians and Surgeons, and an MD from Harvard Medical School. He completed his residency in pediatric ophthalmology fellowship training at Johns Hopkins Wilmer Eye Institute. Prior to his position at OHSU, Dr. Chang was Associate Professor of Ophthalmology and Biomedical Informatics and directed medical student education in ophthalmology. He is also the past chair of the American Academy of Ophthalmology Medical Information Technology Committee. Dr. Chang's primary research focuses on the application of biomedical informatics to clinical ophthalmology. His key areas of interest include telemedicine and artificial intelligence for the diagnosis of retinopathy of prematurity and other ophthalmic diseases. He's also interested in the implementation and evaluation of electronic health record systems and clinical workflow. He's interested in computer-based image analysis for clinical diagnosis, and his clinical practice includes both pediatric ophthalmology and adult strabismus. We're very much looking forward to Dr. Chang joining us officially as NEI Director later this fall. In the meantime, I'm happy to announce that today he's joining us for our open session of council, and he might even surprise us with a few words a little bit later. I'd also like to welcome Dr. Jennifer Schultz, who's joined the Division of Extramural Activities as a Scientific Review Officer. Dr. Schultz came to the NIH in 2011, serving as an Assistant Director in the Division of Receipt and Referral in the Center for Scientific Review. She joined NHLBI as a Health Science Policy Analyst in 2015, and then in 2016, she joined the Division of Extramural Activities at NCI as a Scientific Review Officer. She received a PhD in neuroscience from the University of Pittsburgh, followed by a postdoctoral fellowship at the Salk Institute. She was a tenure-track investigator at the Uniformed Services University, studying the role of blood-brain barrier-associated perivascular cells and brain inflammatory responses in mild traumatic brain injury. And finally, I would like to add my thank you to Kathy's, to Dr. Ann Schaffner for serving as Acting Director of DEA since the untimely passing of Paul Sheehy in January of 2019. During her time as Acting Director, Annie has served with enthusiasm and a deep commitment to serving the NEI mission. I know that you found her a wonderful council partner, and The news is, and very sad news for some of us, is that Dr. Schaffner will be officially retiring from NEI and the government service on November 3rd. So that's very quickly and right around the corner. So please join me again in thanking Dr. Schaffner for her extraordinary contributions to the NEI and to wish her well in the next chapter of her life. She also has a new grandbaby, so congratulations, Annie, on the newest addition to your family. So next, before we get to the agenda and presentations, I'd like to share with you some of the topics that have been occupying many of us here at the NIH. Obviously, NIH has been spending an enormous amount of time developing programs in response to COVID-19. NIH has developed several cross-institute and public-private initiatives to address COVID-19. One example is the COVID-19 supplement through the new social, behavioral, and economic health impacts of COVID-19 and health disparity and vulnerable populations initiative. I know that's very large. We call it SBE for short. One of our council members, Dr. James Coughlin from Smith Kettlewell Eye Research, recently received a COVID-19 supplement as part of these initiatives. So congratulations to James for bridging the gap into COVID-19 research and proving that these trans-NIH partnerships can benefit everyone. Another private-public partnership is the ACTIVE partnership. ACTIVE stands for Accelerating COVID-19 Therapeutic Interventions and Vaccines. This program has been extremely active, no pun intended, and it's evaluated hundreds of available therapeutic agents with potential application for COVID-19. It's prioritized the most promising candidates and designed and harmonized 4 adaptive master protocols for clinical trials. The beauty of these protocols is even if you're not part of the ACTIVE partnership, pharmaceutical companies are encouraged to use the protocol so that they can later on share data, and there can be a coordinated effort in evaluation of multiple investigational efforts as they become available. Since our last meeting, the NIH has made significant progress towards several projects within the ACTIVE portfolio. There are currently 5 active parts to this portfolio. ACTIVE 1 involves a phase 3 trial to enroll adults hospitalized with COVID-19 to evaluate the safety and efficacy of at least 3 immune modulators in combination with remdesivir. These trials will be announced today. ACTIVE 2 is a phase 2, which is expandable to phase 3 trial that's enrolling non-hospitalized adults with COVID-19 to evaluate the safety and efficacy of a monoclonal antibody along with other treatments. Eli Lilly has a monoclonal antibody that's the first therapy in this trial. ACTIVE 3 is very similar to ACTIVE 2 with the exception that this trial is looking at patients with COVID-19 who are hospitalized. So this is an inpatient trial. Unfortunately, this trial was placed on pause this week as there appears to be an adverse event, and the DSMB is reviewing that and should make a decision in 2 or 3 weeks if they're going to release the hold. ACTIVE 4 contains 4 separate trials for blood thinners that have been launched to test their efficacy in preventing and treating COVID-related coagulopathy. 2 are based for outpatient visits, and 1 is an inpatient trial. 1 is for convalescing patients after a hospital discharge. ACTIVE 5, which just launched this week, and it's a study to determine whether approved therapies or investigational drugs that are in late-stage development show promise against COVID-19. And this is called the Big Effect trial, because the plan is to look at combination of all of these drugs right away and to be able to pick out which are working and which are not, so you can move them along the pipeline a little bit quickly. Approximately 100 volunteers will be assigned to each arm of the study, and they'll be testing no more than 3 investigational treatments at any one time. NIH has also launched several vaccine trials against COVID. There is a Moderna trial, which I'm sure you have heard about. That's a partnership between NIH and NIAID and Moderna. It's an mRNA trial. Pfizer is also conducting an mRNA trial that's ongoing. That's not an NIH trial. Pfizer is doing their own thing. However, we do have information on their trial. There's an investigational trial that's a partnership between Oxford and AstraZeneca. Some of you may know that that's also been placed on hold, at least still in the United States. The hold's been lifted in Europe. There is another trial which will be coming on board, which will be from Sanofi and GlaxoSmithKline. And that's looking to come on board probably in December. And then another one, which is Novavax, should probably come on board next week. They've been experiencing a little delay. There's another trial, which is from Johnson & Johnson, and that one was just put on hold this week for, again, an adverse event. Another program that the NIH has been spending considerable efforts on is in diagnostics, and this is the Rapid Acceleration of Diagnostics Initiative. And there are actually several sub-initiatives within this RADx program. So there's RADx Tech, which is testing new technologies, and it's sort of like a Shark Tank scheme in which very early technologies are being run through a Shark Tank-like situation, and then those that pass several reviews are moved forward along the pipeline. To date, NIH has awarded 22 awards to biomedical diagnostic companies, and these are both for point-of-care diagnostic tests as well as for laboratory tests. There's also the RADx ATP program, and ATP stands for Advanced Technology Platforms. These are for diagnostic tests that are a little bit further along in the pipeline, so they don't have to go through the Shark Tank, but then they pick up later on in the pipeline. As of this week, RADx Tech and RADx ATP are being melded into one program. There's also the RADx UP program, and that is for underserved populations. And this program is to understand the factors associated with disparities in COVID morbidity and mortality, and to lay the foundation to reduce disparities for the underserved and vulnerable populations. So over this last month, NIH has put out several funding opportunity announcements as part of RADx UP, and we have awarded nearly $234 million across 32 institutions and 26 states. Just this week, an award was issued for a coordination and data collection center, and that was awarded to Duke at UNC. And then the last program that's part of the RADx program is called RADx Rad for RADx Radical. And that's supporting new non-traditional approaches to diagnostic testing. So all of these RADx proposals are all geared towards diagnostics, and with the goal to get more than 1 million tests out on the street to be able to be run in any one day, whether they be point of care, laboratory-based, and even at-home testing. The awards for RADx Rad are hoped to be made in December. NIH is also developing a seroprevalence network, and they'll be looking at surveys, antibody testing, reference panels, and standards for titers, and that'll be in conjunction with the CDC and NIST. And more information about SeroNet and the seroprevalence activities will be forthcoming in several weeks. NIH has also been shifting to an intramural response, like most of your organizations and academic institutions. Most of NIH's personnel is working from home. We do have a laboratory presence on campus that's limited. We have less than 50% staff on campus, and we juggle the staffing. But some of our intramural investigators have realigned some of their research, and they're conducting research into COVID-19. We're also looking very carefully at our extramural response to COVID-19. And of course, one of the very many questions we keep getting is, how will we make our grants whole? Does NIH plan on making our grants whole? And unfortunately, at the moment, even with a stimulus package being bandied back and forth between the House and the Senate, it's not likely that any stimulus supplements that we get will be able to make the grants fully whole. This was also a conversation that the IC directors had last month with the AAMC Council of Deans. We met virtually, And of course, their number one concern was, can we make grants whole? But what we are doing at NIH is we're exercising maximum flexibilities that we can in terms of deadlines, carryover of funds, and no-cost extensions. So if you have any grants, questions, please contact your POs or the NIH Grants and Funding website for more information and updates on how the flexibilities can be used and how they might be applied to you or your colleagues. Another question that we had gotten from the AMC Council of Deans were concerns related to how the effects of lack of progress would impact people's competitive renewals. And NIH has assured them, and so I'd like to assure you, that there will be no penalties assessed for lack of progress. All the study sections are going to be very much, the emphasis will very much be on science and not progress. There's even been a guide notice that NIH has put out to that effect, so I encourage you to read that. We all understand that this is a global pandemic and no one expects that anyone will be making a lot of progress over this last year. The other question that we dealt with the Council of Deans was hiring and the difficulties for postdocs and others to be finding jobs. One thing that we did learn was that 54% of the schools are still hiring, and that's because they had money saved for a rainy day, and so this certainly qualifies for a rainy day. So there is some concern about those folks who are right on the edge of either in their last year of a fellowship. What we're doing at NIH is we are, and especially at NEI, is we are looking to extend those individuals who are in their last year so that we give them a little bit more of a bridge and they're not out on the street without a job. So I'd like to switch gears a little bit from COVID-19 to tell you a little bit about some of the other things that NIH has been working on. The social unrest taking place around the country and COVID-19 exposed health disparities that cause our underserved populations to bear the greatest burden of this disease. The loss of life in these communities has spurred NEI and NIH to redouble our efforts on behalf of these communities. There have been many meetings here and many conversations about potential pathways forward. In recent weeks, Dr. Collins and Dr. Tabak have had the opportunity to speak with 2 NIH groups to discuss equity and areas of potential bias. The first group was the Intramural African American Senior Investigators, including NEI's Dr. Charles Igwagu. They discussed the status of the NIH Intramural African American scientists and how to improve recruitment here and the career development of African American investigators in the NIH program. The second group that NIH leadership met with is a group called ACRE, and that's short for 8 Changes for Racial Equity. And that group is made up of members from all across the NIH community who serve in various roles and are motivated to ensure that NIH workplace culture is one that's free of discrimination and harassment. So I want to say here that NIH as a whole is committed to investing in permanent change to better serve and support our underrepresented communities, both in the workforce, education, and our patient populations. NIH has recently created 5 trans NIH committees that will report to the NIH Steering Committee and will report to the NIH Advisory Committee to the Director. These committees will address 5 interrelated but distinct work streams. And just recently, instead of calling them the 5 Committees for Change, they are under an umbrella title called UNITE. And that's an acronym that stands for Understanding Stakeholder Experiences. So it's basically a listening and learning and self-assessment committee. The N is for New Research and Health Disparities and Inequities. The I stands for looking at the internal NIH workforce and its culture and how to improve it. The T is for talking and communicating with both our internal and external stakeholders. And the E is looking at our extramural workforce and the culture that exists there and what we can do to influence change in those areas. The committees are made up of folks that represent all aspects of the NIH workforce, There are 3 co-chairs for each committee with 11 additional members, and they represent administrative staff, extramural staff, and intramural staff. I'm not going to tell you much more about these activities as they're still evolving, and they'll be discussed further next week at the NIH Leadership Forum, which is basically a 2-day retreat for IC directors. This topic and COVID-19 will be the main topics of that leadership retreat, but I guarantee that you will hear more about what NIH will be doing in this area, and we'll be reaching out to all of our stakeholder communities to talk about some of the changes we'd like to implement and hope that everyone will partner with us in these activities. While NIH is still developing to address these issues, I can tell you that the NEI, we're looking at how we evaluate, how we hire employees, how we develop them, how we promote them. We're conducting portfolio analyses to ensure that ophthalmic medical issues affecting underrepresented groups are being addressed. We're monitoring our clinical trial cohorts for full representation of minority groups. We're also looking at our grant selection process for potential hidden bias. And we're also participating in a number of NIH initiatives, including the RADx UP initiative, that specifically address testing in underrepresented and underprivileged group. At NEI, we've been discussing elements that have 3 broad themes. That's increasing representation of underrepresented scientists and physicians in vision science and ophthalmology, and not just to stop there, but to also develop programs that continue to help them to succeed once they enter into these fields. Also tied to that first concept is outreach and working to build a pipeline. And I know in the past, we've all talked about, building a pipeline, and we started graduate school or college, but we've been talking about early pipelines, K through 12, and how we can go about doing something like that. We're also targeting research in vision health in minorities. And to do that, we've also started a partnership with the National Institute on Minority Health and Health Disparities to develop funding opportunities that address disparities in vision and eye health in minority and underserved populations. That's a concrete example of something that we can do. For vision research, we'd be the subject matter experts, but it's an opportunity to get other people interested in vision and eye disease who normally look at disparities and who might not already have an interest in eye disease. So we're very excited about that. Our extramural folks are also developing and will publish a NOCI aimed at attracting diverse applicants to the Parent F32 Individual Postdoctoral Training Grant. We're also reaching out to our external partners. We're working with the Diversity Initiatives Committee at ARVO to develop a science video competition for high school students. The ARVO committee works every year to engage high school students from minority populations in the region where the meeting is being held. And students are typically assigned mentors and invited to the meeting. Now, we know in 2021, ARVO is scheduled to meet in San Francisco, and it's still unclear whether it'll be a combination virtual in-person meeting. But that being said, we're still going forward with this new initiative, and we proposed launching a video competition to invite students from schools with a high proportion of minorities to participate. The students will be asked to make a short video about what excites them about science, some of the projects they're working on, experiments they've done, processes they've learned about. They're going to be asked to be very creative with their videos, incorporating music, dance, art, animation, whatever medium they wish. We're also starting to reach out to 5 minority schools in the San Francisco Bay Area, and we'll be working with their science teachers to determine categories and timelines for this competition. Winning entries will be judged through crowdsourcing and shared online by both NEI and ARVO. And if the meeting is in person, we will be encouraging the winners to attend the meeting. And if the meeting is virtual, we've been talking about inviting them to the NIH at the point where everyone is actually allowed to return to the workplace. We've also been discussing expanding our diversity in vision research and ophthalmology intern program, and we have already expanded it. The normal DIVRO program is a summer intern program, and now DIVRO 2 is expanding this program for individuals who wish to train throughout the year without the hard stop in the summertime. We're also expanding DIVRO in another area, which right now we're calling DIVRO 3.0, and we will be talking about that more soon. We're also developing a DC-wide program for underrepresented minority in 3 residency programs to facilitate training of residents in vision clinical research. And this would have the added benefit of plugging in minority ophthalmologists into the NEI system for recruitment at various levels. These are by no means all of the programs that we're considering, but I wanted to give you a sense of some of what we've been doing in this area. And that's it for the remarks. And now it's my pleasure to introduce Dr. Mike Chang, who is here today as our guest. Dr. Chang will tell you a little bit about himself, but I have to ask that you please refrain from asking him questions related to his vision as director, as he's not allowed to comment about his vision or plans for the future until he's officially appointed. And we'd like to not get him in trouble before he's actually starting as director. So everyone, please join me in welcoming Dr. Chang.
Well, Santa, thank you so much, and thank you for everything that you've done, in this position, and what really you and Paul have done over the years. I'm looking forward to working with you, and I want to also just sort of add, I've been reading these comments about Annie, and none of those comments surprise me. That Annie, congratulations, and when I was starting as a reviewer, you did enormous amount to really make me feel welcome, and I've always appreciated that. And I'll miss not being able to work with you, and I'm getting, of course, excited to get to know Kathy in this capacity. But Santa asked me to talk for about 10 minutes on just my background, and so I've prepared a slide. It's just one slide, and that talks about that. So let me just put that up. And so this basically, I would just start by saying that, how did I get to, do what I do? Well, I was raised in a family where almost everybody was an engineer. The one exception was my mom, who was a nurse. But besides that, almost every single person did engineering. And that really did a lot to shape my worldview. So I was born in Pittsburgh. And why Pittsburgh? My parents moved to the US from Taiwan a few years before I was born. And my dad was a grad student at Carnegie Mellon University. And so, when I was a couple years old, we moved to Detroit, Michigan, because he took a job at Ford Motor Company. And Detroit's what I would consider my hometown. And, my childhood had a lot of, almost all the toys that we got had some sort of engineering theme to them. And so when it came time to grow up and go away to college, I just assumed that, what else do you do besides study engineering? And so I went off to Stanford University, studied electrical engineering. And then during that, Silicon Valley was a very exciting place to be, I think back in the late 1980s, early 1990s. But I had 2 summer experiences. One of them is that I worked in a company startup company in Mountain View, California, that built cardiac ultrasound machines. And then I basically did some circuit design for them. And I spent another summer working in a lab in the medical school where we basically wrote simple computer programs to analyze images. And those images happened to come from cardiac ultrasound machines. And it really fascinated me that you could build machines and use them to help treat patients. And it's stuff like that that really inspired me to go into medicine. How can you use knowledge and knowledge discovery to advance, to basically help people? And so I thought I would build cardiac ultrasound machines and help test them to diagnose patients. And so went off to medical school, and I trained in a program that was a collaboration between Harvard and MIT called Health Science and Technology. And at the time, this is now the early to mid 1990s, one of the very hot topics was computational neuroscience and things like artificial neural networks. And I really gravitated toward that. And I actually thought, well, I can become a neurosurgeon, and maybe I can understand how the brain works, model it using computers, and then operate on the brain. And spent some time there finding, well, how can I learn about this area? And ended up working with somebody, Dick Masland at MGH, who was in the Division of Neurosurgery research. And basically spent 3 years in Dick's lab, and that's was very formative to me. That's, Dick is the person who I feel like I really learned science from and how to do, rigorous research. And again, he studied sort of anatomy and electrophysiology and circuitry in the rabbit retina. And, that's really how I learned about vision and, visual neuroscience. And it's what convinced me to become a ophthalmologist, not something else. And so the other thing I did as a medical student was I met the person who became my wife, Lydia, who's a pediatrician. And so we moved to Baltimore, Maryland, Johns Hopkins, and I studied ophthalmology. Lydia studied pediatrics. And at the time, this is now the late 1990s, early 2000s, all of medical documentation was paper notes. It was handwritten notes in paper charts and X-ray film, and started to think, well, maybe we don't need more people who build devices, like what I thought I would do back, when I was in college. Maybe we need people to manage data. And so I learned about the field of biomedical informatics and thought, well, maybe this is what I can spend my career doing. Now, at the time, there really wasn't a clear career pathway, for people who did that. It wasn't a normal thing. And because Hopkins and NIH were so close, I wrote to Karl Kupfer as a senior resident. And so this is probably 2000, and said, well, look, is this feasible to do? And he invited me basically to Bethesda for the afternoon. So I drove up to NEI, spent half a day with him, and it was extremely formative, because what I took from that is, you could do that, but you basically just have to figure out how. And so, I spent really hundreds of hours trying to learn, well, how could I do this? And it was very complicated and very confusing. And met 3 people eventually. One of them was Ted Shortliff, one was Justin Sarin, one was John Flynn. So Ted he's an internist by background, and founded the informatics program at Stanford University, then moved to Columbia to head the department there. Justin did a lot of telehealth research, and it had nothing to do with ophthalmology, but it was diabetes and home care. And John Flynn basically was at the Bascom Palmer Eye Institute and was actually one of the founding ophthalmologists there, and did a lot of work in retinopathy of prematurity. And so basically, from talking to them, thinking about that, that I thought, well, maybe we could do telehealth for retinopathy of prematurity diagnosis, and that I could do that at Columbia University. And so it was awesome. Spent 9 years at Columbia, and first as a National Library of Medicine fellow, and then on the faculty in ophthalmology and informatics, and wrote my first K grant, and got funded with my first R01. And Don Everett and Heyman Chin were my initial program directors, and were very formative in terms of how I thought about science and career development. And after 9 years at Columbia, moved to Oregon Health and Science University, Casey Eye Institute, where have had a great time working there. We built a program in ophthalmic informatics and did some of the things that Santa talked about. Have gotten interested in genotype-phenotype correlation. Done some studies involving retinopathy of prematurity, and how does the clinical care and the artificial intelligence, sort of image analysis, and how does that relate to genetics of disease? And have had, the R01 shifted over to Grace Shen as the program director, and we built a T32 program and K12 program, and have really enjoyed working with Neeraj Agarwal, and really have had the privilege of mentoring several people who've gotten their R01s now that I'm still involved with, Michelle Rybar and Pete Campbell. So really, about and the other thing I guess I'd say about OHSU and Casey Eye Institute is that during the past couple of years have taken on an administrative role there, where basically helped to run the Department of Ophthalmology with it's three of us total, and it's a department that has about 80, 90 faculty, and the annual budget's about $80 million. So it's not like NEI, but it's I've learned a lot from doing that and had a great time. So I guess I would say that I'm really looking forward to this position, and there are some of you on the council and really in this group that I know quite well, and there's some who I know a little bit, and there's some who I really haven't met, but I'm looking forward to getting to know everyone. I'd say that in terms of what have I learned from this, the reason I put this first slide up is that, what have I taken from this? Well, number one, I think that mentorship is really important, crucial, especially for early investigators. Number two is that the reason I put the names of all the program directors and the grants up on the slide is that this has really impressed upon me how critical of a role NIH plays, and how critical of a role individual program directors have played in supporting my career development, and really the career development of investigators overall. Number three, I would say that it's one thing that I've learned is that it's really critical to identify what I call high impact problems. In some ways, I've learned that, of course, picking the right problem is sometimes just as important as doing the work, and I think that's exciting. And another thing that I've learned is how important interdisciplinary collaboration really is. The reason that we talk about things like biomedical informatics and all these is that in my career, I've really benefited from meeting other people, getting others interested in areas of potential overlap, and have really been impressed by how many smart people there are in the world who just happen not to also work in the exact same field, but sometimes getting those people together. I think I've really been inspired by the power of that. And lastly, I would say that the final lesson would be how difficult it can be to translate scientific principles into real world care that helps patients. We built artificial intelligence system, and we've been working in this area for almost 10 years for eye disease. And what we'd like to be able to do is take that and be able to help real babies. And we've gotten FDA breakthrough status from that. And I think that I've really recognized how writing the paper and doing something to treat somebody, there's a lot that goes into that. So anyway, with that, that's a little bit about myself, and really, Santa, thank you again, and look forward to getting to know everybody in this group more and more over the years.
Thank you, Michael. I think I can speak for everybody else when I say that we're all very much looking forward to your official start date, and you can start putting all the pieces together. What he didn't tell you is that we sent him an owner's manual of what it's going to be like to be director, and it's 400 pages, and he is painstakingly reading every page that we have sent him. So kudos for him. I hope it makes some sense, and it will hopefully make more sense over time as he joins us officially, and hopefully that will be soon. Now I turn the meeting over to Kathy so that she can take us through the agenda. Kathy?
Great, thank you. It's nice to meet you, Dr. Chang, virtually. We have a couple of talks, additional talks. The next speaker is Ms. Karen Colbert, and she's the NEI Budget Officer, as you know, and she'll give an update on the NEI budget. Karen?
Good morning, everyone. I'm going to share my slides. Okay. Again, I'm Karen Colbert, and apologies, I need to stop my video. My apologies.
Karen, it's actually okay if you leave your
Okay.
video on.
Okay.
I've looked at the
Fine.
video cast and I think it's fine, so.
Okay, my apologies. Okay, thank you so much, Kathy. Again, I'm Karen Colbert, the NEI Budget Officer, and I'm very pleased to be with you this morning to provide our budget update. As you know, the last fiscal year ended about 2 weeks ago. So what I'll do is I'll give a brief recap of how we ended fiscal year 2020, and then share with you what we know at this point about the budget for 2021. This first slide shows our total estimated spending for fiscal year 2020. Right now, we're in our reporting phase where our spending for the previous year is collected and reported to the Department of Health and Human Services and ultimately to Congress. And so until that official reporting happens, all of the information that we share is considered an estimate, but this is a very good representation of how we ended last fiscal year. The table to the left shows what was spent in each funding mechanism with nearly $700 million for extramural research, which includes all of our grant mechanisms and R&D contracts. We have a little shy of $94 million estimated for the intramural research program. And of course, the intramural research program funds internal principal investigators and fellows conducting basic, translational, and clinical research. And then the remaining $31 million in research support covers administrative, logistic, and scientific support for NEI programs and includes administrative functions such as awarding grants and contracts, planning and evaluation, and other management activities. Our spending by category, 85% for extramural research, 11% for intramural research, and 4% for research support is very much in line with the funding trends for NIH as a whole. If you were to create a similar mechanism table for NIH that captures the spending for all institutes and centers, you would see that our spending by category is at the same percentage or within a percentage point for each category. This slide shows the progression of funding levels from the President's budget request for last fiscal year through the President's budget request for the current year, FY 2021. NEI and the majority of NIH programs are funded from single year appropriations. And so depending on the source of the proposed funding level, whether it be the current administration, the House, or the Senate, the amounts can be vastly different. And for those who are not intimately involved in budget, the different funding levels might be a little confusing. But I'll say in short, the President's budget is a planning document reflecting the priorities of the presidential administration. And we do keep a closer eye, though, on what the House and Senate propose. In a quote unquote normal year, the President's budget is released on or before the first Monday in February. However, we are of course in a presidential election year, and if there should be a change in administration, the process for producing next year's president's budget and the work to finalize the appropriations for this current year, because we don't have a budget yet, could be delayed further. Currently meeting is the 116th Congress. The 117th Congress is scheduled to convene on January 3rd, 2021. A lame duck session of Congress, which occurs when one Congress meets after its successor is elected, but before the successor's term begins, could decide to clear out any remaining bills so that the new Congress has a fresh start, or they could take a hands-off approach and not move forward any existing legislation, including appropriations bills. But at this point, it's actually impossible to know. Can you all see my video okay?
Yes.
Okay.
Yes.
Fantastic. A message popped up on the screen asking me to share again. Okay, my apologies. Okay, so the FY 2021 President's budget was released with significant cuts to the NIH and subsequently the NEI budget. Again, the President's budget is a planning document which reflects the priorities of the administration, but does not set actual funding levels. Again, in quote unquote a normal year, the proposed funding bills from the House and Senate would move to conference committee. And conference committee is a temporary panel composed of House and Senate conferees formed with the purpose of reconciling differences in legislation that has passed both chambers. When that normal process is followed, we would get what's called a conference mark, which would become our appropriation level. The budget process is quite dynamic and funding priorities can shift quickly depending on what is happening in the country. Here we have the funding by category as presented in the FY 2021 President's Budget Request. When the President's budget is released in February, we actually don't really know what Congress will then propose. So while seeing such a significant cut is unlikely, the FY 2021 President's budget proposed a 7% reduction to NIH and a 9% reduction to NEI. Although, again, these cuts are not likely, we have to plan as if it could be a reality. It's not likely that Congress will agree with the administration's approach, but if by some rare chance they do, we would have to significantly cut the number of research grants and funding overall for extramural research. But again, that's not anticipated. So then we move to where we are today. Where we stand today is that we do not have an appropriation and we are under a continuing resolution through December 11th, which actually takes us past the presidential election. The simplest explanation of a CR is that it is legislation passed by the House and Senate and signed by the president that keeps us open for business until an appropriation or omnibus or minibus bill can be put in place. There are 12 appropriations bills that have to be passed each year to fund the federal government and avoid a shutdown. When the regular appropriations are not passed, an omnibus can combine 2 or more of those bills into a single bill that can be passed with only 1 vote in each of the House and Senate. The term minibus is the same principle as an omnibus. If you recall, the majority of NIH was spared the FY 2019 federal shutdown because most of our NIH appropriation falls within the Labor HHS Education Appropriation, which was packaged in a minibus bill with defense to give us full year funding. The other appropriations were not settled and those agencies were shut down. When we're operating under a CR, continuing resolution, the amount of funding available to us is tied to the number of days covered in the bill. For example, if the CR is for 30 days, we have 30 days of funding available to cover all of our needs until either a new CR is put in place or until we get an appropriation. The CR that we are under right now is for 72 days. So dividing 72 by 35, we have dividing 72 by 365, we have 19.73% of the FY 2020 appropriation available to us to spend through December 11th. Here's a sample of an NIH Office of Extramural Research guide notice. When we're under a CR for extended periods of time, for example, during the transition from President Obama to President Trump, we were under CR through May. There is an impact to grants administration. Typically, the NIH Office of Extramural Research will post a guide notice so that all involved will understand how to operate under the CR. This happens to be an old notice from last year, but they pretty much look the same from one year to the next. I have a call out here of the very small text that you can't see in the notice that speaks to how we handled non-competing awards. There are also instructions for other activities, but this says NIH may issue non-competing awards at a level below the commitment of record, generally up to 90%. Then, when we receive an appropriation, many of those awards would have to be revisited. Some institutes and centers also even restrict the number of new awards made during a CR period. And these are just some of the implications of not receiving an appropriation by October 1st. Here we have House Resolution 7614 which is the 2021 appropriations bill covering NIH. Here we have the proposed funding for NIH, and on my next slide, I'll show you the proposed funding for NEI. Appropriations bills are intended to be passed in what we call regular order, meaning full passage of all 12 bills through both chambers of Congress and signed by the President by the start of the fiscal year on October 1st. For the FY 2021 appropriations process, the House has passed all 12 bills, but the Senate is stalled. I'll share more about where the Senate is in their process shortly. This House bill proposes a $5.275 billion increase for NIH. I will note, though, that $5 billion of that increase is proposed in the form of emergency supplemental funding and is not built into the NIH base budget for future years. Without that emergency supplemental funding, NIH would be relatively at the same level as last fiscal year. And also shown in the table, $8.587 billion increase over the president's budget. You know, that looks good for presentation purposes, but as I mentioned previously, the president's budget is a planning document that's not built with a base budget that at least the House at this point has considered viable, evidenced by the House's proposal to increase and not cut the NIH budget. Here we have the House proposal for the NEI budget. The House bill language shows two levels, with and without the emergency supplemental funding that I mentioned previously prescribed for NIH. Without the emergency funding, the House proposes less than 1% increase to the NIH budget. With the emergency supplemental funds included, the House provides a significant increase of 7% to the NEI budget. And so moving on to the work of the Senate. As I mentioned previously, the Senate is stalled in their work to resolve any of the appropriations bills. Here you have the members of the Senate subcommittee that controls our appropriation. Roy Blunt from Missouri is the chairman. And we actually hope to see some movement in the Senate coming fairly soon. It's unclear at this point how the Senate will proceed, though. Because there's been no movement in the Senate, we could actually see a draft bill coming from Chairman Blunt that does not have subcommittee consensus, but reflects his own priorities. That draft bill might not go into markup at the subcommittee or full committee levels, but the likelihood of that right now is unknown. The upcoming election actually could have a significant impact depending on whether there is a change in administration and or a change of control in Congress. These transition years tend to be extremely unpredictable. So if Chairman Blunt should decide to produce a draft bill that funds his priorities, it's helpful to know what those priorities might be. There's no way to tell at this point what a bill like that might include, but if we want insight into what any senator or congressman might be a champion of, it's a good idea to look, at their official web pages to see what they are promoting. This press release from about 10 days ago was actually posted on Chairman Blunt's webpage. And here he commends HHS for making additional COVID-19 relief funding available for mental health and addiction treatment. As the press release states, Chairman Blunt has led efforts in the Senate to make behavioral health a priority in the COVID-19 response. So clearly these are priorities of his. The question is whether NIH might benefit from a bill that he would put forward. Finally, I've included this slide to highlight that the House bill does include language that funds the 21st Century Cures Act at the full level in FY 2021 of $404 million. The bill language includes $109 million of Cures funding for the All of Us program, with an additional $391 million of non-Cures funding, bringing the total to $500 million. $100 million of Cures brain funding, with an additional $400 million of non-Cures funding, bringing that total to $500 million as well, and $195 million of Cures money for Cancer Moonshot. The current authorization of the Cures Act ended funding for regenerative medicine in FY 2020. However, the House bill language for 2021 does encourage continued support of ongoing research in that area. That concludes the budget update, and I thank you for your time today. And so now I'll take any budget questions. Stop sharing.
Are there any questions for Karen about the budget? If not, thank you, Karen.
Thank you very much.
Appreciate it. Okay, our next presentation will be a brief summary of the NIH Council of Councils meeting from Dr. Russ Van Gelder. He's a member of our council, obviously, and NEI's representative to the NIH Council of Councils. Dr. Van Gelder?
Great. Thank you, Kathy. Can you hear me okay?
Yes.
Great. Welcome, Kathy, to your first council meeting, and Michael as well, and Annie. We will truly miss you around this table. I'm going to give a very brief overview of the Council of Councils meeting from September. So I presented a bit of this last time. The Council of Councils is a group that reports to the Director's Office, and specifically to the Division of Program Coordination, Planning, and Strategic Initiatives, which in NIH speak is DPCPSI. That's led by Jim Anderson, who has been at the head of that. He's Associate Director of the NIH and has run DPCPSI for the last decade or so. The Council of Councils has one representative from each of the 27 NIH institutes and centers, and I am grateful to have been nominated and accepted to represent the National Eye Advisory Council on this group. This is a picture from our January meeting, which was, in my tenure now, our only in-person meeting. We also met virtually in May and September, and I'll be reporting out on the September meeting. So the major thing that the group does is, aside from serving as the actual counsel for the ORIP, the Office of Research Infrastructure and Planning, is to do concept clearances similar to what we do for the NEI, but to do this for the DPCPSI Director's Office Common Fund. And there were 5 of these proposals that went forward. I want to bring them to our council's attention just so there's awareness of what's happening at the NIH level. The first one is a initiative to improve biomedical research in artificial intelligence and advanced data science. The second is a nutrition program that coordinates with the All of Us program. The third is a cellular senescence network. Fourth is a renewal of a pediatric research program. And the final one is an intramural research scholars program. The computer science AI program is designed to really engage computer scientists from outside of medicine into biomedical programs. The idea is that there have to be multiple PIs on the grants that would come out of this that would include computer scientists or engineers who are normally not in the biomedical space, along with people who do live in the biomedical space. In terms of examples that were shown to the Council of Councils, this was one, a smartphone acoustic for looking for ear infections using basically reflected sound waves to tell what the compliance of the tympanic membrane is. Obviously something similar to many of the ongoing efforts to do telemedicine via smartphone in the eye with smartphone-based fundus cameras and so forth. I bring this forward to this group because NEI was not part of the initial IC participation list in this initiative. I think we could contribute significantly. As you heard, I think it was last council meeting from Aaron Lee. Really, NEI has a leadership position in AI. In fact, the only FDA approved AI device right now is the image recognition for diabetic retinopathy. And I would encourage NEI leadership to add its name to the list here for IC participation in this funding opportunity, presuming that it goes through the Director's Office. The second program that we cleared was the Nutrition for Precision Health, which was a basically offshoot of the All of Us research program, which is a very large genomics, proteomics, multiomics program to understand population-based precision health. The proposal here is really to take a subgroup of the All of Us cohort. look at the diet in those individuals, and then do several smaller controlled studies of alteration of diet and see what this does to many of the omics outcomes, including the intestinal microbiome and serum omics. Again, this is sponsored by multiple institutions, primarily driven by the Diabetes and Digestive Disease Institute, but also NCI and NICHD. NEI is, again, not a participant in this particular one. Obviously, again, with our interest in nutrition for macular degeneration and the really groundbreaking work that Emily Chu and Rick Ferris and colleagues did in that space, we might have a role here, which could be explored. The third one is perhaps the most interesting, I think, to NEI, and this was a proposal for a cellular senescence network Directors Fund program. And this was put forward by Richard Hodes, the director of the National Institute of Aging, and Ned Sharpless, the NCI, National Cancer Institute director. And you can see it's a fairly large proposal of about $150 million over 5 years. Senescence is an emerging hot area in biomedical science. The idea that there are cellular markings of age and really a whole built-in program of cell life that ends in this senescent phase has really taken off in the past few years with the identification of very specific markers for senescent cells. They're relatively rare in the body, but they seem to put out a cytokine and a proteome milieu that influences many cells around these senescent cells. Several groups have succeeded in clearing senescent cells from the body of animals. And the results that have been published are pretty remarkable. For example, clearing senescent cells in mice seems to forestall development of arthritis, and from our perspective, cataracts in mice, as well as osteoporosis. Again, this is a multi-institute initiative. NEI was not part of the initial group that developed this. I think this one we have a very, very strong interest in because really our major causes of blindness, macular degeneration, glaucoma, and cataract are all diseases of senescence. And I think it would be wonderful to see the NEI involved in this mechanism, assuming, again, that the director's office puts it forward. Council did approve moving forward with this. The fourth concept clearance that we had was a pediatric concept clearance. This was the Gabriella Miller Kids First Pediatric Research Program. This is largely another omics collection across institutes, primarily directed at childhood cancer and structural birth defects. It's a smaller initiative, $12 million a year. These are some of the diseases that they are looking at for doing whole genome sequencing, as well as omics and things like Ewing sarcoma, scoliosis, neuroblastomas, and so forth. This is not a huge space, obviously, for NEI. I think the genetics of retinoblastoma, the major childhood genetic cancer, are quite well understood. There are certainly many congenital abnormalities that do affect the eyes that might fall under this. I'm not sure, though, that NEI has a huge dog in this race. And finally, the Lasker Scholar Program, which is an NIH intramural research program to recognize outstanding clinician scientists and provide salary support for their tenure track years for 5 to 7 years, along with an interesting sort of escape hatch that if these individuals wish to leave NIH at the end of their term, that they have an R00 that they could take with them anywhere for 3 years. This is a program that has been in place for the past 10 years. The Council of Councils needed to do a reauthorization for the RFP to go back out again. NEI has taken advantage of this, and we have 2 current Lasker scholars, Kathy Kukris and Nita Sen, both of whom have been very successful. And the council did approve, with some conditions, reauthorization on that funding mechanism. So I'll stop there, and I'm happy to take any questions that councilors or others might have.
Great, thank you. Santa had noted in the chat box that NEI has signed on to the Smart Health Initiative now. So I know you had recommended that. So I just wanted to mention that. Are there any questions for Dr. Van Gelder?
That was this is Mary Ann. That was a very good report, Russ. I was going to ask the question as to how NEI gets involved in these processes and why we weren't involved initially. I guess maybe you could give me some insight in that.
Yeah, I actually don't have much insight into the development phase in terms of how an initiative comes forward. My sense is that the directors of the ICs bring these forward to DPCPC for consideration, but maybe Santa can provide some additional insight into how these consortia are formed as these initiatives go forward.
Sure, and Mike Steinmetz, you can feel free to chime in whenever you want. So some of these programs come forward as the result of a few folks getting together around a topic and they form a workshop. And often we have representation on the workshops in the form of our program directors. Sometimes that's where the programs stay, and then sometimes they get carried further, but we don't always hear about it until after it's formed. So, and that was the case with the Cellular Senescence Network. So that there was an original working group that was looking at aging, and from that, there was some talk at last year's leadership retreat about cellular senescence, and then all was quiet, and then suddenly there was, so we started this Cellular Senescence Network, and this is who's part of it. And so we did inquire, and Michael Steinmetz and I have been talking about whether or not we should be joining that network as well. For the nutrition, we also didn't hear about that one. There was a working group that I have asked Emily to serve on that is very focused on nutrition. And so what happens is sometimes NIH, when they start something, they split them off. And so you think you're on the main thing, and then suddenly there's 50 main things. And so we're working to get better at making sure that we are included in these conversations and reaching out to some of the directors actually directly to make sure that we are included. I've been getting a lot of, oh, we didn't think you'd be interested. It's like, ask us first and we'll let you know, kind of thing. So that's the way it has been working. Michael Steinmetz, did you have anything you wanted to add to that?
Thank you, Santa. Appreciate that.
Yes, there used to be a fairly large committee that include representatives from all the ICs that Common Fund employed to vet potential programs, and actually went around the country and got community input. And in those days, we knew what things were being considered and could participate. This has largely faded into the background lately, and as Santa said, we often don't know about these until we hear them from the council meetings, or if they happen to get brought up at an IC directors meeting. So Russ, any information that you have about new things in the pipeline, please let us know. We're happy to sign on to these things. We get substantial amount of monies to NEI grants, supplements, and funding of our awards from all of the OD offices, and we're happy to participate in anything that has relevance to us.
Yeah, the total dollar amount of these concept clearances, I think, was close to $500 million from this last council. So there is quite a bit of funding embedded in these programs. Some of the programs actually require the institutes to provide a good chunk of the funding, but others are money from the director's office that we would like to see some of that obviously come to NEI when we're programmatically relevant.
So I believe in 2020, we received almost $13 million in funding from the OD offices to our grants.
So can I ask a question? Thank you very much, Russ and Michael, and thank you very much for the clarification. I was wondering, does it, if we are not included in the group, does that mean the money doesn't come to NEI to be able to support funding if an investigator is indeed interested in that area?
No, the only, I mean, we can always sign on these, to these at any time that we know about them, so we don't miss out on the funding. What we do miss out on, though, is the planning stages, and to make sure that that NEI priorities are included in the initiative from, you know, from the early stages. So we miss that input, but we don't miss the funding simply because we weren't aware of it at the stage that was going on in.
But as an example, I mean, in the cellular senescence network, where they're doing an atlas of senescence cells in the body, the retina was not included in the initial discussion, and that's happened before with other large atlas type. You know, if you go into the databases of single cell RNA-seq and so forth, you're lucky if you can find an eye tissue in those. And so I agree with Mike that the earlier that NEI leadership can be involved in those discussions, the more likely it is that there will be opportunities for us to participate.
So do you, Russ, do you have, or Michael, do you have any idea, or Santa, like how we can be proactive, I guess, in getting that? I mean, or...
So, I mean, we will join the committee. We will put a representative from NEI on the planning committee so that we get involved in it. But just to give you a sense of the scope of this, at last count, my staff are on 134 trans NIH work groups and committees, 134.
Oh, okay, thank you.
All right.
One
Thank
more
you.
question.
Oh, I'm sorry. Was there another question?
Yes. Russ, I wanted to know if there is room for adjustments, like once the program is accepted and it's ongoing, can there be modifications?
Yes, so basically concept clearance allows the NIH director's office then to move to the next step, which is formal planning and the development of requests for applications. Typically it'll go out, you know, through the usual program announcement mechanisms, and those will be modified after the concept clearance by the discussion around the council. So it's not like things are set in stone the minute the council approves it. In fact, that's really just like with our own concept clearances, that's the beginning of the process that gives the leadership the green light to go ahead and put these in place. So absolutely they can and often are modified after concept clearance. And so there is an opportunity for additional input. I get the sense, again, I've only been to 3 of these Council of Council meetings now, but I do get the sense that a lot of this discussion of what the scope of these are is occurring at the director level and between ICs through the director's interactions. And I think for Santa and for Michael, there's a great opportunity just through intra-NIH networking to try to increase the visibility of vision research in some of these initiatives. We have hosted several of these initiatives over the years. I think the Director's PN2 grant on nanotechnology originated and was hosted at NEI. And of course, regenerative medicine, we've been in the lead on that as well. So I think there's also opportunity as we in vision science have areas where we have a natural leadership position to put some of these forward and bring other institutes in as partners as well.
I totally agree, Russ. And actually, one of the things that happens when a new director gets sworn in is that he or she gets to do a meet and greet with all of the NIH directors. And so I think that will be an opportune time for Dr. Chang to be able to express his interest to other IC directors for some of the things that, you know, that they're involved in, and getting us a little bit more visible on some of these other projects.
Great, thank you. And thanks for the nice discussion. Our next presentation is from Dr. Shefa Gordon, who's the Director of the Office of Program Planning and Analysis. And he's going to present an update on the NEI strategic plan.
Good morning. My name is Shefa Gordon. Let me share my slides. So my name is Shefa Gordon, and I am the head of NEI's Office of Program Planning and Analysis. Once again, the powers that be have strategically placed my strategic planning talk between you and a break, so this time I'll take the hint and keep things brief. This October, Council marks about the 1 year since we started developing the strategic plan. I think I can speak for all of us that it's been a very, very long year. Actually, the process of planning started a little bit earlier. I initially came to Council in 2018 with the concept of a cross-cutting strategic plan that addressed the statutory requirements established in the 21st Century Cures Act that was passed by Congress in 2016. But the message from Council at that time was pretty clear. We needed to create a process that could communicate NEI priorities to Congress, but that also served as a functional tool for the scientific community, for Council, and for NEI staff in charting the future of vision research. And Council also wrestled with the tension of developing a plan that was creating a document that kind of reflects the totality of vision research versus a more limited yet strategic list of priorities. So we went back, and the process we developed was designed to produce two parallel documents, a public-facing plan and a more detailed implementation document. In order to complete a plan by the end of 2021, which marks the 5th year since the passage of that 2016 Cures Act, we need to continue this process even as the search for a permanent director, NEI director, was ongoing. So the past year has centered around a broad information gathering phase. Once our new director has started, we will finalize that public-facing plan and concentrate on an implementation phase. I have included in this timeline where we are here. Here is, let me see if you, again, can you, yeah, we are here. Can you see my mouse? With Council, we've met, we've had our panels have met, we've drafted plans. Most of the plans have gone to panels for review. Although I think the neuroscience and immunology plans will go out shortly. Otherwise, all the other plans have been reviewed by our panels. And in this timeline, I've placed kind of a target date of around the next Council for when we might publish the public-facing plan. But that really, of course, depends on the new director will want to review progress to date and discuss the priorities of an implementation strategy with our extramural staff and internally before we finalize this document. When we started this process last October, we discussed that historically, NEI planning involves creating 6 panels based around our core anatomical programs, which are retina disease, corneal diseases, lens and cataract, glaucoma and optic neuropathies, strabismus, amblyopia and visual processing, and low vision and blindness rehabilitation. The last time we did a comprehensive plan, as you can see here, was 2012, and for each area we had highlighted progress, needs, gaps, and opportunities. Based on Council's previous feedback from this plan, we proposed a new way to organize the process, so our panels will be based on cross-cutting areas of emphasis instead of NEI core programs. Once again, Council, in your wisdom, did not exactly endorse my original proposal, but after some tweakings following last October's Council meeting, you endorsed these 7 areas of emphasis arranged in 3 research domains. So the first domain is visual system in health and disease, which include areas of from genes to disease mechanisms, biology and neuroscience of vision, immune system, and eye health. The second domain was capitalizing on emerging fields. This is where NEI is a natural leader. These are regenerative medicine and data science. And the third is preventing vision loss and enhancing well-being, which is covered in individual patient quality of life and public health and disparities research. At the January Council last year, I discussed the request for information that we used to kick off our information gathering phase when we asked what are the significant discoveries in vision research since our last plan, 2012, what new opportunities were enabled by these scientific discoveries or technology development, and what needs and gaps in research and in health and quality of life should be addressed by NEI. As I mentioned in January, we're really pleased with the robust response. We had over 250 responses from researchers, but from patients and caregivers. really span the gamut. And some key themes that came out of this was the need to address cerebral visual impairment, access to care, vision screening and telemedicine, health disparities, and behavioral research, just to name a few. And then at the June Council, I reviewed our preliminary panel reports, the highlights for each area of emphasis. I'm not going to go into all those details today since I did cover them at the last council. For each panel, we had asked for 1 to 2 volunteers from council. Think of those of you again who volunteered. We then chose 2 external co-chairs shown here who helped us identify 12 to 13 experts for each panel, in addition to the 2 to 5 NEI planning and program staff. And for each panel, our extramural staff really tried to make sure we covered all our major programs: retina, cornea, glaucoma, myopia, things that, because we weren't organizing our plans around these panels, we want to make sure all our major areas were covered. And then we also worked really hard to achieve diversity with regards to gender and race, ethnicity, geography, age, area of expertise, degree, some PhDs, MPHs, optometry, ophthalmology, practicing clinicians, members of the public. We had panelists who were blind, partially visually impaired, fully sighted. And since I presented this in June, we have since completed all our panel meetings. The last one was in August, and we have drafted plans. And like I said, the plans are largely have been reviewed by the original panels, although we still have a few that are haven't been reviewed by the panels yet. So as we wrap up the information gathering phase and we're transitioning to implementation phase, we're again going to wait for our new NEI director until he's on board. But fortunately, he can hit the ground running. I was personally very pleased to learn that the co-chair for our data science panel, Dr. Michael Chang, was selected as a new NEI director. We did not know that he was a candidate when we asked him to co-chair one of our panels, but we're very happy that he was involved in the process. Aside from his chapter, he won't review the rest of the plan until he's on board, so you know, a little while yet. But we will work with him as he shares his priorities for planning and how they fit with the panel reports. As this plan does falls under the auspices of council, it's your plan. We will, of course, seek your review and input before we finalize the public-facing document as well as implementation. So this includes your input on where we can start implementation. Of the many opportunities that have been identified in the different panels in a plan, our extramural staff, planning office, and NEI director will take a close look to see where we can put priorities and what we can, the low-hanging fruit, where we can implement before we finalize the public-facing plan. We make sure that our implementation and our public-facing plan are, of course, in alignment. I want to end on something that's been a little fun for us. When NIH did their NIH-wide strategic plan and released it in 2016, the last page had a list of 14 bold predictions. These were stretch goals that might be achieved if there was stable funding and intense scientific effort. And then Dr. Collins took the 45-page plan and presented all the details to Congress at a hearing. And to be frank, Congress didn't seem too interested in all the details, but they really loved this, the bold predictions that you see here, and they kept asking questions about that. So we took that as a sign that we can have this kind of a visioning conclusion to our plan. Now, I have to say that of these bold predictions, NIH satisfied or successfully completed about 4 out of the 14, even with some of the intense scientific effort. So they are both kind of a vision, but also kind of a statement of where we are. So we asked all of our panels to come up with a list of bold predictions. Now, not all the panels did handle this kind of differently. Some panels had all their members send in ideas and then voted on their favorites. Others just submitted a few, and largely they were basing on the ideas that came from the needs and gaps that they identified in their panel. So hopefully if we fund those, we can reach the bold predictions. They're not meant to be pie in the sky, but actually things we can potentially achieve in a 5-year time frame. But again, they're like stretch goals that really reflect our priorities. So we're only aiming to have about 15 total to cover all of the research. We have way more than that already. Dr. Cheng will have to make the final selection. We did have panel vote on a little bit priority schedule. We want to make sure that we balance across all of our portfolio for these bold predictions. I have just kind of cherry picked a few of my favorites here, but this by no means reflects our priorities. I just wanted to kind of weigh your appetite. Your homework is to kind of look at these, and either we can discuss some other bold predictions to add to these lists, or you can, for homework, you can send some in to us. So here's some initial bold predictions. In 5 years, the efficacy of the first iPSC-derived products will be demonstrated in patients with AMD. In 5 years, control over the gene expression of genes in specific cell types will enable the restoration of vision to those suffering from retinal degeneration. Strategies to promote immune homeostasis, such as autologous regulatory T-cell therapy or a novel biologic, will transform the treatment of ocular inflammatory disease, greatly reducing the need for systemic and steroid medications. Newly discovered genes will be leveraged to develop new candidate therapies for glaucoma. A new evidence-based test battery and classification system for cerebral visual impairment, CVI, will allow clinicians to recognize and diagnose 80% of CVI cases in children before they start first grade. Therapeutic interventions targeting the microbiota through a combination of antibiotics, dietary interventions, fecal transplants, and probiotics will begin to show success in clinical trials for the long-term management of intractable immune-mediated diseases. A comprehensive blueprint of the visual system will be revealed, allowing new approaches to understanding, maintaining, and repairing sight. So I'm mixing up ideas that came from all the different panels without saying which panel they came from. This was a neuroscience suggested recommendation. Clinicians will have the ability to restore immune regulation in chronic disease so that novel therapies such as cell-based therapeutics or gene therapy can face a more hospital microenvironment for cell survival and function. Classification of ocular, inflammatory, and oncological conditions and their response to treatment will be transformed by deep learning algorithms on multi-omics data, microbiome, transcriptome, metabolome. We have a complete catalog of retinal cell types in multiple mammals, including humans, that reveals their gene expression profiles, circuit connectivity, and contributions of vision. And page 2. 3D printed prescription lenses will reduce uncorrected refractive error in populations with health disparities. Large databases will be developed for retinal imaging for a large variety of retinal, uveitic, and degenerative diseases to allow AI machine learning analyses to determine biomarkers for diagnosis and treatment outcomes. Americans will be able to obtain a retinal exam that yields useful screening and diagnostic results through a mobile phone and online video platforms. Telerehabilitation, I think that's a word, will be an effective and acceptable method of delivering services to individuals with low vision and allow for their participation in research. AI and visual head displays will transform the eye clinic, making it more effective at diagnosing, monitoring, and preventing visual disease. Websites and graphic material will be accessible in a practical manner to individuals with visual impairment. Technology will exist to reprogram adult non-plastic brain to behave as a developing plastic brain. Establishment of a new non-human primate model will enable new clinically significant discoveries in macular neural circuit research that is not possible in smaller mammal retinal models. Advanced automotive technologies, I assume that means self-driving cars, will support the safe operation of motor vehicles by those with visual impairment. Optimized machine learning AI tools for clinical setting will improve diagnosis of early stage or challenging conditions such as early stage glaucoma, diabetic retinopathy, or trauma-associated damage or dysfunction. As we know, our incoming director, Dr. Cheng, has something like that he developed for retinopathy prematurity. And finally, those with visual impairment or blindness can engage with the world as effectively and efficiently as fully sighted individuals when accessing information, transportation, education, employment, and performing daily activities. So I'm going to stop there. As I said, I welcome additional bold predictions. We have a list that's longer than we're going to include in the plan, so we're going to have to pare this list down. But the more ideas, the merrier, because or we're not going to throw this list away. We will keep it, maybe we'll hang it up on the wall so we can inspire us as we go about plotting our research. So thank you for your attention, and let me know if you have any questions.
Thank you, Shefa. Are there any questions? People really need a break, I guess. People should feel free to send feedback to Shefa, and the slides will be made available as well after council meetings. So don't feel like this is your only opportunity. With that, we are going to take a short-ish break. Let's take about 10 minutes and plan to return here at 11:48. Thanks all. Okay. Assuming that everybody's back and want to stay on schedule because we only have a short lunch break planned. So our next presenter will be Neeraj Agarwal. So every October, he provides you with an update on the NEI loan repayment program. Dr. Agarwal is NEI's program officer for training and will present the update.
Thank you. All right, so my name is Neeraj Agarwal, and I'm the training director for National Institute in the Division of Scientific Program. So as mandated by Congress, I will be presenting to you the loan repayment program status for the fiscal year 2020 we just ended. Yeah, so what's the purpose of loan repayment program? The purpose of loan repayment program is to attract health professionals, clinicians, scientists, etc., to a career in research by paying off their educational debt. Next. So what are the LRP eligibility? It's similar to K awardees. So one has to be a US citizen or a permanent resident. One should be involved into patient-oriented clinical research and be able to devote 50% of research effort. So all my K awardees, since they are committed to 50 to 100% of research time, so they automatically are eligible to apply for loan repayment program. It's open to MD, PhD, all the dual degrees, etc. And if you are involved in private practice, you are not eligible, or for a for-profit organization. Next. So NIH will repay your educational loans backed by US government and also by other commercial lenders such as Bank of America, etc. Next. But it will not pay your bad loans or your personal loans such as your mortgage, other delinquent loans, and also your spouse's educational loans, etc. NEI participates into 3 major categories of loan repayment program, that is clinical, pediatric, and recently for the fiscal year 2020, we added health disparities research. So what it does, it pays off your $50,000 of debt per year, plus the accrued IRS taxes. It used to be $35,000 per year, but from the fiscal year 2020, we increased that to $50,000. It's renewable, it's multiple time. You can, once you apply, and then you are eligible to apply multiple times till you pay off all your loans. It is a mentored program, so you need to have a mentor. And then, as I said, all the K awardees also have a mentor, so they automatically are eligible with their research time also dedicated towards research. NIH grant support is not required, so you don't have to have a K award or R01 or R21 or any other kind of grant funded from NIH. It's an online application, it's a short application, it's peer reviewed, and deadline is always November 15 of each year. So it's a once a year submission date every year for November 15, so the deadline is coming. So this is the data to show the fiscal year 2020. And here, if you see, we funded 93% of our applications. And if you compare that with NIH, NIH was like 51%. And the new applications, we funded 86% and the renewal 100%. Then the allocation amount for the fiscal year 2020 was $1.8 million. Next, if you go back to fiscal year 2019, we funded 81% compared to 57% of NIH, and our allocation was $1.7 million or so. Next, I think this is a report, and if you have any questions, I will be happy to answer. Thank you.
Thank you, Neeraj. Are there any questions about NEI's loan repayment program? Okay, thank you. Hearing none, we'll move on.
Sorry for the mess up.
I'm sorry?
I'm sorry for the mess
Oh,
up.
no worries. No, we're fine. You're fine.
I'm going to start now.
Thank you. So our next presentation is going to be from Dr. Steve Becker, who's the Director of the Office of Regenerative Medicine. He's going to provide us an update on the NEI Audacious Goals Initiative and the Regenerative Medicine Innovation Project. Steve.
Thanks so much. Hopefully everybody can see my slides.
We can.
Great. It's my pleasure to give some updates about the regenerative medicine programs. Starting with our Audacious Goals Initiative. As you know, this started in 2013 as a prize competition, and this was trying to catalyze vision research over the next 10 to 15 years. The ultimate aim was determined to restore vision through regeneration of the retina, specifically focusing on photoreceptors and retinal ganglion cells. We're doing this through strategic research funding, and our most recent funding opportunity was released last month and was to develop translation-enabling models to evaluate survival and integration of regenerated neurons in the visual system. The due date for this funding opportunity is January 15th, and the program officer for scientific contact is Tom Greenwell. This is a busy slide, but it kind of summarizes what we've been doing for AGI over the past couple of years, and I just wanted to briefly update where everything stands. On the top left corner, we outline the 3 consortiums that we currently have. The Functional Imaging Consortium has 5 projects, and they're all currently in no-cost extensions. We're planning on holding a symposium to highlight their progress in February, and we'll update that information when it's finalized. Our Discovery Consortium is identifying regenerative factors that may be important for the transplantation or the endogenous stimulation of stem cells. And we hope that the data coming from those projects will be posted on a data portal hosted by St. Jude's later next year. You might note that a lot of these works from both of these consortiums have been recently published. Recently, David Hyde and Seth Blackshaw had a science paper describing how there were shared pathways in zebrafish and mammalian retinal regeneration, and elucidating perhaps some of the ways we could harness how zebrafish regenerate their retinas to aid that regeneration in higher mammals. And then finally, in September 2018, we had our Translational Models Consortium, first one set up with 5 projects with a variety of different species. They recently gave us an update on their progress, and despite some understandable COVID delays, they're making their milestones and progressing quite well. Below, we kind of summarize a lot of the meetings and workshops that we've held. Our most recent one was the Human Retina Biology and Perception Workshop this past February. all these workshops have white papers associated with them in which we summarize kind of the state of the science and identify the needs, gaps, and opportunities. So from all this progress, we've been contemplating how to move forward, and the next meeting to help us do this is planned for November 9th, and we're terming it a road mapping meeting. And it's going to allow NEI staff to come together with a lot of the thought leaders that have participated in those activities that I recently discussed. So these include the AGI Steering Committee, the co-chairs of all the previous workshops, the external scientific oversight committee members that advise on the various different consortia, as well as the recent panelists of the Regenerative Medicine Strategic Planning effort. And so we're interested in getting those folks together to help us plan out and prioritize the next steps for our initiative in the next 3 to 5 years. And we hope that this can be published and summarized for the larger research community. And to give you a sense of the kind of questions we're asking, I've listed some sample questions that we intend to address at this meeting. So we're really wanting to make sure that the barriers to imaging the retina have been addressed in a variety of animals and eventually humans. We want to make sure that we have the techniques and methodology to test the functional restoration of vision circuits in a variety of animals and humans. We want to make sure that the challenges to photoreceptor and retinal ganglion cell integration are being addressed. And we want to see the effects of surgery, the phenomenon of material transfer, and the disease environment are accounted for when designing these important transplant experiments. And then we want to see how we can bundle all this together so that we can get to having clinical trials start in the next 5 to 10 years. Next, I'd like to pivot to our 3D Retina Organoid Challenge. It's a prize competition that was started back in 2017, first as an ideation challenge and then as an implementation challenge. And it's really to improve the 3D retinal organoids as an in vitro model that can be used for disease modeling and drug development. Earlier this month, the final deadline had passed, and those submissions that were received are now in our technical review period. These technical reviewers are subject matter experts, and their comments will be fed to a federal panel that will ultimately help us decide whether to award any awards from this competition, and then the announcement would be made in December. Next, our AMD Integrative Biology Initiative. I'm pleased to announce that the New York Stem Cell Foundation has added additional iPS stem cell lines that are from AREDS2 AMD patients. Originally, there were 11 lines. Now there are a total of 46 lines, and an additional 47 patient-derived lines will be available by the end of the year. In addition, we're setting up a data portal for clinical information, image data, and genetic information to be available from the AREDS2 cohort that's undergoing final review, but we hope in the next few months that will be made available to the larger research community. In addition, there's isogenic controls being made of the first 11 lines, and we hope those will be available sometime next year. And already we've received requests from even labs around the world for many of these lines. And to request these lines, it's a simple email to folks at New York Stem Cell Foundation at repository@nyscf.org, and you can obtain more information about these lines. Next, I'd like to turn to the NIH Regenerative Medicine Innovation Project. You heard previously that this was a program started by the 21st Century Cures back in 2016 and authorized $30 million to support clinical research in adult stem cells. Interestingly, this program requires the federal funds to be matched And for any trials that use an FDA product, that approval for that trial must be in hand before the NIH award can be made. In addition, anyone with these awards have consented to submit representative samples of both their source stem cells and their stem cell derived product for independent characterization. So recently, the fiscal year 20 clinical project awards were announced. 2 of them are for vision research. One of them by Dr. Tejalian is for MSC secretions to promote cornea regeneration. The other one is for Jeff Stern, who is looking for a treatment to dry AMD using a stem cell RPE population to replace RPE. In addition, a more recent funding opportunity for additional clinical trials has recently ended for FY21, and I list that at the bottom. Just to remind folks, the previous year, vision research was also well represented. Of 8 projects, 3 of them were again for either treating AMD through RPE efforts or for RP, retinitis pigmentosa, using some gene editing correction, as well as transplantation with Stephen Seng's effort. All these were 2-year awards for pre-IND efforts, and we're hoping that those will carry on into clinical trials. A lot of the regenerative medicine innovation project efforts are to create infrastructure and serve as a template for the wider field of regenerative medicine. And so the in-depth cell characterization solicitation for those independent labs recently closed, and an award to 1 or more of those labs are expected by the end of the year. Those providers are going to use data standards and common data elements to maximize the interoperability of data to advance regenerative medicine research. In addition, the regenerative medicine community is in discussion with a group called the Clinical Data Interchange Standards Consortium, which will develop clinical data standards for regenerative medicine for clinical indications. And this is being done in collaboration with FDA. Because of the large representation of AMD and RPE biology, we expect that the fields are really going to benefit from this standardization and this infrastructure being provided by this program. Lastly, we have a number of updates to the Office of Regenerative Medicine website. We're planning on launching different resources, and if you go to the NAI website and search Office of Regenerative Medicine, you can see some of the latest events coming up, including a seminar series and some updates about future programming. With that, I'll stop there and happy to take any questions.
Thanks, Steve. Are there any questions for Steve about AGI or regenerative medicine? Okay. All right. Thanks, Steve. Okay, so we have 3 concept clearances to present to you today. These are concepts for potential funding initiatives. We present them to you to get your input on them and provide you with an opportunity to share your thoughts and suggestions to NEI staff to help shape these initiatives. Following each presentation, I will ask for a vote to approve the concept for further development into a possible funding opportunity, an RFA, a PA, or some other type of opportunity. So with your approval, if you approve them, NEI would plan to proceed with the development of the concept. The first concept is for a reissue of the NEI program announcements for the Collaborative Clinical Vision Research and Resources projects, which will be presented by Dr. Marianne Redford, who is a program officer with our clinical research group. Marianne?
Yes, thank you. So as Council is well aware, all NIH funding opportunity announcements, or FOAs, have an expiration date, generally 3 years from the date of issue. And at that time, they reviewed for and assessed for continued relevance and updated as indicated and reissued if applicable. So the NEI UG1, which is our cooperative agreement mechanism, clinical trial FOAs are up for renewal. There are 3 companion announcements: the study chair clinical trial FOA, the coordinating center FOA, and the resource center FOA. And most often in our case, resource center is utilized by image reading centers for our large scale clinical trials. So we did review the existing FOAs, intend some minor tweaks to update preferred NIH language, some personnel changes, and a few changes for greater clarity. But we're hoping to reissue them. And I'll remind, as veteran council members are well aware, any UG1 clinical trial within a possible funding range are explicitly brought to council's attention during closed session and discussed. And in fact, I believe this afternoon, we will be covering 2 of those. Any questions? I'm not seeing any. So Kathleen, I'll give it back to you. Thank you.
Okay, if there are no questions, as I mentioned, we do need to vote on these. So I'm going to ask for a vocal motion to approve.
So moved.
Thank you. Is there a second?
Second.
Gardner, yes.
Thank you. And I'm going to do this the easier way. If there's anyone who is not in favor of approving these concepts, please speak up now. Okay, I will take that as unanimous in favor of reissuing these program announcements. The next concept is for an anterior segment initiative and will be presented by Dr. Human Araj, who manages several portfolios at NEI, including ocular pain, lens and cataract, ocular motor systems, as well as strabismus and amblyopia.
Thank you, Kathy. So I'll start by sharing my screen. And go to presentation mode.
Looks good, Human.
Thank you. So last October, we updated Council on a new initiative that we have been developing, the Anterior Segment Initiative, or ASI. ASI is based on the following observation. In examining the human visual pathway, it is clear that we are capitalizing on unique opportunities present in the back of the eye through the Audacious Goals Initiative. We are also capitalizing on opportunities upstream of the visual pathway through the NIH Brain Initiative. And so this raises the question, what about opportunities at the front of the eye? Now, the following are 5 lines of support that converge on a proposal to comprehensively dissect the innervation of the anterior segment. These 5 pillars are request for information, ocular pain and sensitivity workshop, ocular pain program, cell census network of the Brain Initiative, and the Dry Eye Workshop 2 report. Let's take each one at a time. Here's the first line of support for our proposal. In order to broadly capture the vision research community's feedback on the unique opportunities and needs present at the front of the eye, we issued an RFI, for input on research opportunities on the anterior segment of the eye. The response outcome that we got was very robust. Over 200 stakeholders from academia, nonprofit societies, and private industry provided in-depth comments on around 25 topics related to the anterior segment. Here are the top 15. A number of these contributions pointed out the need for new models and technologies like imaging, cell mapping, and integrative biology. Others had a more clinical focus and raised the need to target ocular pain, dry eye, and the related tear glands. Which gets us to the second line of support. Several years ago, a workshop on ocular pain and sensitivity was held at NEI. Ultimately, 7 key areas were identified. One of these key areas was inflammation. And therefore, as part of our ASI, we will be holding a workshop on inflammation in the anterior segment to better flesh out the gaps and opportunities. This will be a virtual meeting to be held in April of next year and will be chaired by Drs. Riza Dana and Nida Sen. So stay tuned. Among the other areas, functional innervation, molecular and cellular mechanisms, and central mechanisms of sensitization to ocular pain were identified as key needs. For example, the panel pointed out that little is known about the factors that regulate corneal innervation or the differences between corneal nociceptors and spinal nociceptors. Similarly, while the transition from acute to chronic pain happens in some patients, but not in others, is not understood. Not to mention, pharmacological interventions for ocular surface pain by modulating nociceptor sensitization is practically lacking. And so based on this workshop and guidance from Council, the NEI established a program on ocular pain. And here's a snapshot of our program. The histogram illustrates the number of applications received and the number of grants funded. One is struck by the small number of applications within each key area in the last 10 years. What we also find is that while multidisciplinary teams and approaches are viewed favorably in peer review, reviewer enthusiasm is limited by a lack of understanding of the big picture. And applications on ocular pain are frequently affected by double jeopardy. So if an application goes to a vision-centric CSR study section, reviewers will tend to address the ocular aspect, but not the pain aspect. And vice versa, if the application goes to a non-vision-centric study section, the reverse happens, with reviewers tending to address the pain aspect, but not the ocular aspect. All the while having to deal with the same application page limitations. So clearly something needs to be done. Now, in parallel with the NEI interest in understanding and alleviating ocular pain, the NIH, as you know, has been undertaking the BRAIN initiative. One key component of this initiative is the Cell Census Network. The goal of BICCN is to molecularly, anatomically, and functionally identify and characterize all the different types of cells in the brain. All of them. As you can imagine, our lonely ocular pain circuit gets overshadowed by the multitude of other circuits that the BICCN is currently investigating. And so this gets us to the 5th line of support for our proposal on anterior segment innervation. The vision research community has been well aware of the importance of understanding ocular sensation and pain. In fact, the Tear Film and Ocular Surface Society has recently issued an incredibly thorough report based on the deliberations of the 2nd dry eye workshop. In particular, a subgroup of ocular pain experts tackled ocular surface pain and sensation. And wisely, they divided their task into describing what's currently known about the neuroregulation of sensation, tearing, and blinking. So let's take a look at one of these pathways, the ocular pain circuit. So far, So for us to feel a stimulus at the surface of the eye, we would need this, which senses the stimulus. It needs to get all the way to the cortex, which processes what that stimulus was. In between departure point and destination point, there are three main stations along the way: the trigeminal ganglion, the trigeminal nuclei, and the thalamus. So a stimulus, which can be mechanical, chemical, or thermal, will trigger a neural signal that's transmitted along the trigeminal nerve, right? And to the first station, the trigeminal ganglia. From there, the neural signal gets filtered and continues on to the second station, the trigeminal nucleus, where neural modulation takes place, and then continues on to the thalamus, where more neural processing takes place before the signal makes its way to an ultimate destination in the insula and primary somatosensory cortex. So we have a trigger or a stimulus that goes through primary, secondary, and tertiary connections until it makes its way to the cortex, which tells you what to feel, be it pleasant or painful. Now, superimposed on this ocular pain pathway is the tearing reflex that controls the lacrimal glands. It too is initiated by trigeminal primary neurons innervating the corneal epithelium. The trigeminal innervation of the ocular surface, including the cornea, conjunctiva, and lid margins, provides the afferent limb of the tearing loop. These are the yellow pathways. The autonomic innervation of the lacrimal gland, on the other hand, provides the efferent limb of this loop. These are the green and red pathways. The nature of the relay between the afferent and efferent fibers in the superior salivatory nucleus is still unknown. So we have this cascade. Free nerve endings in one of the most densely innervated tissues in the human body contain the nociceptors for touch, chemicals, and temperature. They transmit the stimulus to the trigeminal ganglion containing the cell bodies for these primary corneal afferents, and then onto the brainstem's trigeminal nuclei. From there, the cortical projections regulate the functional responses, be it sensation, tearing, or blinking. And so this brings up an interesting link among sensation, tearing, and inflammation. In dry eye, reduced tear secretion leads to inflammation, which causes sensitization of polymodal and mechano-nociceptor nerve endings and an abnormal increase in cold thermoreceptor activity, together evoking dryness sensations and pain. Long-term inner inflammation and nerve injury in turn alter gene expression of ion channels and receptors at terminals and cell bodies of trigeminal ganglion and brainstem neurons, changing their excitability and connectivity. The underlying molecular, structural, and functional disruptions in ocular sensory pathways ultimately lead to ocular neuropathic pain. Now, of course, what we've described is the general wiring plan for the ocular, tearing, and blinking circuits. That part is known. What is unknown is the critical detail of the underlying molecular biology and how that's integrated with anatomy and function. In fact, the neural pathways involved in the regulation of the meibomian gland secretion have not been identified. Similarly, the efferent fibers that evoke goblet cell secretion of mucin are still unidentified. And so what we want to see are projects that cross two or more of these levels of analyses: the anatomy, the molecular biology, and the function. Our ultimate goal is to bridge all three levels of analysis. We want integration. Now, why is dissecting these circuits so critical? because they are integral to understanding the adaptations that result in neuropathic ocular pain and dry eye disease. The adaptations can be at the peripheral nervous system or the central nervous system. PNS sensitization may involve corneal sensory afferents or the trigeminal ganglia themselves. CNS sensitization, on the other hand, may involve the subcortical trigeminal nuclei or the cortical level of the thalamus and primary somatosensory cortex. Furthermore, along with the ascending pathways, descending pathways may also be involved in potentiation. Bottom line, understanding the pathophysiological mechanisms of peripheral and central adaptations will greatly advance the field of ocular pain and dry eye and hopefully shed light on the vexing question of transition of acute nociceptive pain to chronic neuropathic pain. So in sum, our proposed initiative will request ideas for detailed yet integrated analysis of anterior segment innervation at morphologic, molecular, and functional levels. Details of the specific funding mechanism, number of projects, level of support, and duration will need to be decided. We plan for as long of an open period as possible in order to give time for applicants to arrange the types of cross-disciplinary collaborations we're looking for. A key feature of our proposal is that our selected projects must work as a consortium. A scientific oversight group will help ensure everyone is on the same page and is pursuing the program's goals in a complementary fashion. There's a need to plan for a repository of the data that are generated. Fortunately, there's a chance we'll be able to leverage some of the BRAIN initiative infrastructure for our needs. Our proposal will entail reaching out to other NIH institutes as well as the oculofacial pain and dental pain research communities. The Office of Research on Women's Health might also be interested in partnering with us given the higher prevalence of dry eye disease among women. So perhaps it's time to pursue an opportune target, innervation of the anterior segment. We look forward to your guidance. And with that, I'd be glad to take any questions you may have. Thank you.
So that was a lovely presentation. I'm really thrilled that you're looking into this because it's a topic that I'm very passionate about. And I think we have, it's a very exciting time that we can be looking into the details of all of this, how the nerves are maintained on the ocular surface. We're beginning to to find out that the nerves are reduced with aging, they're reduced with dry eye, they're reduced or altered in a number of CNS conditions. Why that is and how it interacts with the CNS is just such an exciting area for us to be beginning to get more information about. So I'm really happy that you're doing this.
Thanks so much.
Humam, let me also put my 2 cents in. I think this is a terrific anterior segment initiative from a clinical perspective. Eye pain is a very common associated symptom with a variety of anterior segment problems, corneal, dry eye, scleritis, orbital, and we really don't have great insight into the pathophysiology. The only area I might suggest expanding this into is photophobia. And many patients with anterior segment problems wind up with debilitating photophobia. If you look at patients with graft versus host dry eye, for example, often one of the most debilitating things for their function is that they can't go outside without heavy eye protection. And no one has a clue at this point what that mechanism is. Recent work from Mike Gorin's group at UCLA, Dave Copenhagen at UCSF, Richard Lang at Cincinnati, and Ethan Buer, my colleague at UW, have shown that there are atypical opsins expressed in the cornea, and specifically in the corneal nerves, including melanopsin and neuropsin. And neuropsin in particular is upregulated in response to injury. And there was a nice IOVS paper on that recently. I might suggest also including that in the RFP to look at potentially light-sensitive mechanisms of pain, because it is a big component of ocular surface disease.
Thank you so much for that. So yes, photophobia is certainly on our radar screen, and I think you'll be pleased to know that we've recently, the NEI has recently funded the work from Anna Matinia, who comes in also obviously from Gordon's lab, looking at some of those aspects that you raised. So, and it's definitely going to be tied in with our bigger initiative, this ASI on innervation of the anterior segment.
Yeah, I would like to see it mentioned in the actual RFP when this goes forward, because I think it's an important, very important physiologic component.
Mom, that was terrific. I'm so glad to hear about this. I'm assuming you will also mention about migraine, because there's, I know, interest among our clinicians, our neuro-ophthalmologists, and also dry eye specialists of the connection between dry eye and potentially triggering migraines and vice versa. But we don't know, you know, it's more of an association. So a lot of work could be done there.
Yes, thank you for that. Absolutely. As a matter of fact, you know, the whole idea behind the trigeminal, the three parts of it, you know, having the maxillary nerve and the mandibular nerve and the innervation of the face. So that's something actually we were hoping to get interest from NINDS to partner with us. So it's definitely something we will love to pursue.
Yeah, I think the proximity of the long ciliary nerve in the eye to eventually innervate the cornea come very close to populations of the intrinsically photosensitive retinal ganglion cells. And it's possible that there's kind of interesting crosstalk going on there, which is leading to some of these issues with the pain. And there's just not enough known about those topics right now. And I think it's, you know, the anterior segment people have have shied away from doing the nerve stuff for many years because, you know, we didn't feel like we had the expertise. But and I think, you know, it's time to jump right in, because it's there's enough background now for us all to get excited about different aspects of this.
Great, totally agree.
Any other questions for Humam?
Just a comment. That was a wonderful presentation and very lovely insights into this new initiative. I was just wondering, practical purposes, when these applications are getting reviewed, is there going to be a special panel, or is it going to go to the existing panels that that we have in place?
Thank you. Yeah, so this is a very good point, because one of the big advantages of going with this route with our ASI initiative is the ability to have tailored review, in-house review. And so where we're able to kind of emphasize the aspects that we'd like to build upon for the reviewer. So it's definitely one of the things that we're interested in.
Thank you.
Anything else? Thank you, Humam. So we need to take a vote on whether to move this concept forward. Is there a motion to approve?
I move.
Thank you. Is there a second?
Okay.
I'm sorry. Was there a second?
Second.
Second.
Thank you.
Sorry about that.
So let me again put it this way.
May I ask for clarification? We're approving the motion with the inclusion of something about light and migraine and light sense photophobia in the initiative.
Well, so the specifics of the initiative haven't been worked out, but that's why we bring it to you for your feedback. So we'll certainly consider that and incorporate it. But right now it's just a concept.
Okay. All right.
So you're approving the development, the further development of the concept into a possible funding initiative. If I can kind of, and I speak on that for a bit.
Thank you for that clarification. I appreciate that.
That non-clarification.
Well, you know, thank you.
So is there anyone who's not in favor of further development of this concept? Okay, the motion for approval of this concept passes. Thank you very much.
Thank you.
The last concept that we're going to present today is also part of the Interior Segment Initiative, and it will be presented by Dr. Lisa Newhold, who manages the Fundamental Retinal Processes portfolio. Lisa?
Okay, can you guys see everything okay?
Perfect.
Okay. We are requesting a concept clearance from Council in order to generate a community research resource of microbiota associated with the healthy ocular microbiome. The outline of my talk, I'm first going to give you some background on the methods, as well as a portfolio analysis, followed by some information on a request for information that we put out a while ago on the interior segment, and then talk a little bit about the NEI strategic plan, and then finally present the concept clearance. On this slide, one of the questions is, what is the microbiome? Well, Dr. Lederberg, he won a Nobel Prize in 1958 for his work on microbial genetics. And in his work, he described the microbiome as an ecological community of commensal, symbiotic, and pathogenic microorganisms that share our body. The microbiome, the human microbiome, was established in 2007. And it was established to increase our understanding between the microbial flora and health and disease, to look at the connection. And it catalyzed a lot of scientific advances in the field, most notably the nasal passages. It looked at the oral cavity, skin, the gut, and urogenital tracts. One advantage of this project is that they generated resources and leverage technologies that we can benefit from in order to facilitate the characterization of the microbiome. The data that they also obtained through these projects was demonstrated that the microbiome does indeed play an important role in human health and disease, and represents an understudied diagnostic and therapeutic target. So we're hoping that maybe we could capitalize on a lot of the information that's been found from the Human Microbiome Project in order to start looking at the ocular microbiome and looking at sites for therapeutic intervention. Characterizing the microbiome, there's a couple of techniques that are popular, that are commonly used, and we're not going to include or exclude a particular method, but one of the main methods that is used is the first is the 16S ribosomal RNA amplicon sequencing. And this here is a schematic diagram of the secondary structure of a ribosomal RNA, and the colored areas represent the different domains. And the ribosomal RNA contains both conserved and variable regions. And in this technique, the 16S, the primers that are used to amplify conservative regions. So there's many different types of bacteria that would be in common with that. And what this does is that it enables one to identify communities of bacteria, which can then be used to infer community levels of metabolic pathways and networks. In addition to the 16S sequencing method analysis, they learned from the Human Microbiome Project that there's approximately 80% of the microbes that are not culturable to date, but this method will allow you to at least get down to a specific level as to what the class of microbes are. On the next slide, I just listed the taxonomic ranks. There's 7: the kingdom, phylum, class, order, the family, genus, and species. And the 16S sequencing generally gets you to the level of family and genus. So this method also allows you to capture broad shifts in the community, microbial community over time, and therefore makes it easier to look at global changes associated with health and disease. Another technique that is used is the metagenomic methods, which I put a diagram over here on this side of the metagenomic shotgun sequencing, which is the most common technique. And they basically take the bacteria and isolate DNA, fragment it, then sequence it, and then overlay the sequences to come up with specific, and then come up with specific genomes, they can then go to databases and see what they can pull out as far as what the specific organisms are. And the way this works is that the primers that they're using are to the variable regions, not the conserved regions. So this increases the taxonomic resolution. It also allows for further resolution of the key compounds and metabolic pathways that are stimulated. One of the problems is that it is more costly, but it gets you further beyond the information that you get with the 16S. On the next slide, talk about the NEI microbiome portfolio. We don't have much. We have very little on the microbiome project. And over the last 10 years, we've had approximately 16 grants that were funded related to microbiome. And 11 of the grants focused on the ocular surface, 2 on the oral cavity, and 3 on the effects of the gut on the microbiome on eye disease. And this covered a range of conditions, which you can see down here in blue, which include inflammation, diabetic retinopathy, AMD, and contact lens wear. On the next slide, I wanted to show an RFI that we had put out about a year ago on the anterior segment of the eye. And with this, we had 52 responses that represented more than 200 stakeholders, and because several of them had multiple signatories. And several of the respondents encouraged the NEI to support more work on the effects of the microbiome on eye health and disease. The NEI strategic plan, we're working on the new plan. The Planning Committee on the Immune System on Eye Health panel also recommended work on the microbiome. They basically said that the NEI needed to characterize the microbiome in both the gut and the ocular surface in order to determine what's normal versus abnormal. You have to know what's there in order to know what's changed that is pathological or pathogenical. The NEI also needs more studies to assess the interaction between the dysbiotic microbiota and the immune system. They also recommended that we investigate the connection between microbial communities and interventions such as fecal transplants, antibiotics, diet, probiotics, etc., and other possible therapies. One of the big questions is whether there really is a resident ocular microbiome in humans. There's not much information published in the literature, but one of the things that we came across was published in Scientific American by Tony Ledger, St. Ledger. He's at the University of Pittsburgh and worked with Rachel Caspi. And in that article, he says only recently have scientists concluded that the eye does indeed harbor a core microbiome that appears dependent on age, geographic region, ethnicity, contact lens wear, and state of disease. Okay, the building blocks, what do we need to do? We need more information on what constitutes healthy ocular microbiome in order to compare to disease states. We have to know what is there in order to know what to change or what the changes are that's pathogenic. The Strategic Planning Committee also recommended a consortium. This approach will facilitate, or this approach requires a scientific advisory committee which will facilitate standardization of samples and sequencing. We also need to look at the structural and functional configurations of a resident microbial community from healthy populations. And this data can then be used to pave the way for broader studies, including epidemiology, ecology, and translational applications of the human ocular microbiome. Understanding the diversity and abundance of the resident microbiota is critical for the development of microbiome-based intervention for prevention and treatment of disease. So then the concept clearance, we're asking that council give concept clearance to develop an initiative for community-based resource of microbial communities and factors that they elaborate that are associated with resident ocular microbiome of healthy individuals. So we want to start with healthy individuals, and we thought we'd start with the ocular microbiome because very little is known about it. And with that, I'd also like to thank the Microbiome Working Committee for help in putting together this concept. Thank you. Can you guys hear?
Yep.
Okay. Wasn't sure if I was just talking.
No. So Lisa, thank you so much for putting the work into this and for bringing this forward. By way of disclosure, I held one of those 16 grants. I think that was entitled the Ocular Surface Microbiome in Health and Disease, and have been in the field for a bit. I would suggest, so I'm completely supportive of the concept that we need to understand the normal microbiota of the ocular surface and the periocular region in order to understand health and disease. I have 3 comments around this. First, it is important to distinguish between intestinal microbiota and ocular surface microbiota. These are 2 very different areas, and they're addressing different concerns. There's a great literature from Rachel Caspi and Phoebe Lin and others on the effects of altering gut microbiota on ocular inflammatory disease. And I think that's a very promising area, but it's a very different set of experiments and aims than characterizing the ocular surface microbiota, which was the focus of most of your discussion. So I'm supportive of that, but I would call it out as a separate area if there's an RFP that ends up going forward. The second issue is I would suggest that we not limit that microbiota to bacteria. There are resident viruses on the ocular surface that we don't really know what they do. Those include tortenovirus and Merkel cell polyomavirus. There's also the fascinating world of bacterial phage, which are by number the most prevalent constituent of the ocular surface. And we have no idea whether we mount immune responses to these. It is conceivable that phage drive autoinflammatory responses on the eye surface because they should be immunogenic. They're plentiful, but they're not directly pathogenic to human cells. The third comment is actually the most important. The methodologies that have been developed that you described of 16S metagenomics and to some extent shotgun metagenomic sequencing work extremely well in bacterial-rich environments like the gut. They work extremely poorly in paucibacterial sites like the conjunctiva. The conjunctiva supports a microbiome that by number is about 2 logs less rich in bacteria per human cell than skin or buccal mucosa. So whereas on skin, we have about 100 bacteria per human cell if you sample, or if you take a cheek swab, you'll find the same. In the conjunctiva, you will find less than 1 bacteria per 50 human cells. And if you apply 16S or other PCR amplified methodologies to that site, you end up with an avalanche of artifact. As an example, one of the first papers in this field from 2011, Dong et al. And IOVS showed that there were over 220 recognizable phylotypes from normal, healthy human conjunctiva. When we did quantitative work, and this was work that Thuy Duan, who's now at UCSF, did when she was in my lab, when we did quantitative PCR on that same sample, in collaboration with the lab at Bascom that did the initial work, we found that each swab only had 50 bacteria's worth of DNA on it. You can't get 220 different species from 50 organisms that are on a swab. PCR, 16S PCR in paucibacterial or non-bacterial samples creates a host of artifact. So I would highly suggest that before going into a full RFP, that there be a workshop on standardization of methodologies for understanding the ocular surface microbiome that focus on robust techniques that are typically whole genome shotgun metagenomic type techniques, or very directed PCR techniques with methods for confirmation of findings. Again, if you look through the older literature, you find a host of phylotypes that make no sense, that are bacteria that are never found in human tissue, but are environmental samples that have been found in deep thermal vents and places like that, that clearly are artifactual. And until we settle that, I think NEI would be wasting a lot of money if it pursues a 16S metagenomic approach to doing this cataloging.
Okay. Additional questions?
There are no additional questions. I'm going to do the same thing, ask for a motion to approve this concept for further development.
So moved.
Thank you. Is there a second?
Second.
Thank you. Is there anyone who is not in favor of approving this concept for further development? Hearing none, I'll announce the motion for approval has passed. Thank you to the presenters. Thank you for all the good feedback, which we will certainly incorporate. At this point, before we scheduled lunch around 1:10, so I'd like to open the floor, such as it is, for discussion by council members, to any of the presenters, to Santa, or about any topic that you would like to discuss. And at this point, I think you can, if Lisa, you want to stop, yeah, and I think people can turn on their videos if that's easier.
Does anybody want to talk about or ask questions about anything that we covered early this morning in our remarks, or any other topics, scientific topics or other topics that you'd like to discuss? Now's your opportunity.
Maybe people are hungry, which is understandable. Oh, hi.
Actually, I have a comment. Going back to earlier, I think Santa mentioned giving extra time to some of the trainees, K-99 holders, et cetera, for COVID-related delays. And maybe this is for anybody who's here, who's around from CSR or even Neeraj, are the study sections aware of this? This came up in a gathering yesterday of some Simons Foundation Bridge to Independence. This is sort of like the K-99 of Simons Foundation. Gathering yesterday, and I was serving on a mentoring panel. And several of the young assistant professors proclaimed or exclaimed that the study sections weren't taking this kind of directive seriously, asking for more preliminary data kind of thing. So I'm just wondering whether the training programs are actually conveying the message to the review panels sufficiently. You're right.
I missed your first part of the question, but looks like you're saying these people who are submitting R01s are being demanded for more preliminary data as an early stage investigator.
Yes, and that the study sections aren't taking to heart the COVID-related delays that are impacting the junior people tremendously more actually than the seniors. Or it's affecting everyone, but are the study sections getting the message in their reviews that?
Yeah, I mean, as you heard earlier from Santa in her remarks, like, so even if the R01s, which are competing R01s, we are a little bit laxed in the sense that they are not supposed to be looking for so much progress being made or in the terms of productivity, etc. But I mean, they should be doing it, because the reviewers are in the same situation and they should be understanding, and NIH has conveyed that message. It's a little bit late, I think, but like a couple of months ago. So I think things will change and we are doing everything possible in terms of K-99 awardees, those who are not able to find jobs, to give them extension and also support their research and salary. So I think they should be working on that, and and we will be able to convey them, whatever we can. I think Kathleen, as the DEA in charge, I think now should be able to go, and our own folks in scientific review branch of DEA, I think they should be also able to take care of that. But reviewers are reviewers, like R21, they are not supposed to have any preliminary data, and yet they always demand to have some, But I think they will learn and realize that this is the real problem.
Thank you.
So Carol, just to add to that, it wouldn't be the training study sections that would be reviewing these applications for R01s. It would be the regular study sections that need to pay attention. What we are doing for the trainees is if you're in your last year and you haven't been able to secure a job because, as we heard from Santa, many universities still not hiring, we're giving an extension to the award and funding the salary for that additional year to give more time for people to get on the job market, and hopefully things will open up. That's not an NIH-wide policy. That's an NEI policy that several of the other Brain Institute ICs are also doing.
Great, thank you. It's very laudable.
Yeah, and as Mike said, it was clear from this week's IC directors meeting that many other ICs had not even considered this. So this is going to be something that we're also going to cover at the retreat, since we're all operating from, without extra supplements in this area. Each IC is kind of doing whatever they want to do to try and help. And so we are one of the few that are right now at least extending our trainees for a year.
I think this is a very stressful time for everybody, but for the early stage investigators and the new investigators, this is going to be a particularly, it's much more stressful than usual. At places like my institution, there used to be bridge money, there used to be extra funding for people. There were undergraduates that you could hire to help out, and all of this is gone. And these people for tenure, they're going to be in a lot of trouble. It would be, a mechanism for additional year of not just a no cost extension, but a cost extension for a year at the end of the funding period might be something that's necessary to save the careers of some of these people. We just don't want to lose all of the young women scientists that we've brought into the field because they're having to teach their children at home all day long and can't work as effectively. It's a very stressful time. I know you know that, and I know it's been stressful there too, but we just need to be sensitive to all this.
So NIH, recognizes a special category called at-risk investigators, which are investigators who have a grant now, but if their current renewal or application for a new grant is not funded, that they will lose all funding in their laboratory. And I'm just saw the statistics from FY20, and I'm happy to say that NEI had the highest success rate of at-risk investigators across all of NIH.
I'm glad for that. You guys have been very supportive of us, and we hope we can keep it up and be a beacon for the rest of the NIH.
Yeah, and as you know, and we have for quite some time, NIH as a whole and other institutes have emphasized early stage investigators when, using that as a factor when thinking about, what we're going to fund.
Right, we've already extended the 10-year clock on these people by a year, but I would not be surprised if that ends up being a 2-year requirement going forward, since nobody really expected all of this to last as long as it has. But it hasn't, we haven't made that change yet, but it's likely that will happen.
And furthermore, because of the COVID and if there are some other similar situations, so we at NIH are giving extension for early stage investigator eligibility if they are like 11th year because of COVID. So we are adding one more year to their eligibility and it may go on.
Thank you. That's good to hear, Niraj.
It's good to hear, but how do people know about that? Has there been an announcement?
Yeah, I think so.
Okay, I just didn't see it.
Yeah, I think
haven't seen it
I'll
either.
be able to share that. Mhm.
Any additional questions? This is actually really helpful and reminds us that I think a lot of these flexibilities and changes have been posted in the guide, but it reminds us that we need to be very vigilant about communicating them to the field. Not everybody goes and looks in detail at the guide. So, so thank you for that feedback. Other topics? Questions?
I have a question. I'm at Smith Kennewell Eye Research Institute, and I'm involved in providing IT advice to our IRB committee. We have an in-house IRB committee, and a lot of people are trying to figure out how to do remote work effectively and safely in a way that respects, participant privacy and all that. And I'm just sort of looking for more resources to guide us, specifics like how might I conduct a research study with a participant over Zoom in a way that might be HIPAA compliant. What if there's the need to, with the participant's consent, to save the video for subsequent offline analysis? Is there a way to make that HIPAA compliant? And talking to various MDs and other people, I even asked my program officer, it seems like maybe this is something that a lot of people are trying to sort out. I'm not an expert on IRBs. Again, I'm sort of coming from the IT perspective, but it seems that maybe a lot of people are asking the same sorts of questions right now. So I'm just looking for pointers and resources. Thanks.
I actually can't think of any conversation that we've been having around that topic, but we can certainly look into it for you.
Thank you.
Yeah, Sherry, maybe you can take this to the next OBSSR meeting. It seems like this is a group that would be very interested in that.
Sherry, I unmuted you if you want to say anything.
Oh, yeah. Can you hear me?
Yes.
Okay. I'm not sure. Yes, I'm that program officer that James contacted about this, and it is a really interesting topic. My communication back is there are a number of experimentalists who've been using Mechanical Turk. And I'd actually, like to look into how they're handling this. There are also some very large-scale databases, for instance, on prosopagnosia, that I know have been going on for years, not just since COVID's taken hold. So I know this is certainly something that people have had to address, but I agree OBSSR would be a really good entity to start with. How are other institutes handling this? So I'll definitely follow up with them. And it's a great question, James, really.
Thanks so much.
Especially important now. Yeah.
I'd like to bring up another area for raising awareness for study sections, and that's that for some of the trainees, it can be difficult to get letters of support during the time when their laboratory, when the supporting scientists were actually not allowed to go into the laboratory and may not have been even getting email. So, you know, the letters of support of collaboration are really important in the trainee grants. But during that time, maybe there could be an advice of, you know, how to, you know, what to say. Should the trainee say, I reached out to these people, but they weren't able to, or they didn't respond because they weren't in the office?
Niraj, do you want to, I haven't an answer for that. Niraj, have you heard of situations like that, or I don't know if Brian wants to weigh in about
So this is Brian, can you hear me?
Mm-hmm.
So the letters of receipt, I know, so we review the K-99s in-house, and those letters are screened by Division of Receipt and Referral. So if the letters aren't there, sometimes the applications won't even get through to us. So I would, if they know there's a problem ahead of time, reach out to Neeraj or myself or both, and then we can put them in touch with a receipt and referral, or we can contact them directly. I'm sure, you know, the general NIH policies would be very, give a lot of leeway during these times, but I think we might not know about it because it won't get through to us. So any advance notice, they can contact me or et cetera, Neeraj or both, and then we can reach out to DRR or give them information, because I'm sure a lot of people are having these issues.
Thank you, Brian.
Thank you.
Okay, we are about at lunch. It's going to be a slightly abbreviated lunch. Before we adjourn for lunch, I just want to remind folks that you're gonna log out of this meeting, and you're going to NEI and NIH staff and council members are going to need to log into a separate Zoom link for the closed session. And again, if you don't have that link or you need it to be resent, please contact Annie. Let us know. If you have any trouble logging on to the closed session, again, just reach out to Annie or myself.
Kathy, I'm prepared to send out another email when we get off with the meeting link, so people don't have to dig in their emails for it.
Okay,
great. What time do you want to start the
I'd like to start at 1:30. I know that doesn't give us much time, so I can extend that to 1:35 because that's the kind of human being I am. So with that, enjoy your lunch, and I will see you back here at 1:35. Thanks for a really nice discussion this morning and for all your input.
Thank you, everyone, for joining our open session. The open session is adjourned.